Hello! Yes, and welcome to our first set of notes for the second semester, Objective 15. Objective 15 says, I can solve a system of linear equations by graphing and determine if two linear functions have one solution, infinite solutions, or no solution. So today we're going to do part one of these notes, and we're going to start with just a little bit of review. So I want you to actually do this on your own, kind of dust off some cobwebs. Alright, I'd like you to graph the following lines on the coordinate plane provided, then state the slope, x-intercept, and y-intercept. Go ahead and pause the video, get those graphs done, and then press continue to make sure we're good to go, alright? So go ahead and press pause, and then graph A and B here. Alright, let's check out letters A and B here. So looking at letter A, this is in slope-intercept form, remember? So y equals mx plus b. Alright, where m is my slope, so that tells me my slope is -2. B is my y-intercept, so that tells me my y-intercept is 0, 3. So I can go ahead and graph that at 0, 3. My slope of -2 tells me I'm going to go down 2 and right 1. Down 2, right 1, down 2, right 1, up 2, left 1. And then we're going to connect the dots like so. Gorgeous. Now notice my x-intercept wasn't right on one of these coordinate points. To find my x-intercept, I can just set y equal to 0. So I'll say 0 equals -2x plus 3. I can subtract 3 from both sides. So I'll have -3 equals -2x. And then when I divide by -2 to get x all by itself, -3 divided by -2 will give me positive 3 halves. So my x-intercept would be 3 halves, comma 0, which is about 1.5, which makes sense from what I graphed there. Alright, so that's letter A. Letter B is in standard form, and the easiest way to graph this is going to be to get it in slope-intercept form. So let's subtract 2x from both sides. So I have -4y equals -2x plus 8. And then I'm going to divide by -4, divide by -4. When I do that, I'm going to get y equals -2 divided by -4 will give me positive 1/2. X, 8 divided by -4 would give me -2. So from there, now that I'm in slope-intercept form, I can see that my slope is 1/2. My y-intercept is 0, -2, and let's graph this. So 0, -2 would be right here. A slope of 1/2, so I can go up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2, down 1, left 2. And then I can connect the dots here. Gorgeous. And now this one's nice because I see my x-intercept is the point 40. I can see that graphically. If I didn't know that, again, I can just set x equal or y equal to 0 and solve there. Alright, so now that we've reviewed graphing, let's talk about a new idea, systems of equations. A system of equation is a set of two or more equations composed of the same variables. Now, whenever solving a system of equations, we want to find the value of the variable that make each equation true. All right, now graphically, that would be where the lines intersect. So all we're going to do for this one today is we're going to graph both of these lines, and the point where they cross is the solution. All right, so we just graphed the lines up above, right? Notice these are the same equations. So let's graph them again. One of them was y equals -2x plus 3. So plus 3, and I'm going to go down 2, right 1, 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 up 2, left 1. Gorgeous. And connect the dots, and remember that x-intercept is 3 halves. Beautiful. It's a pretty straight line, not bad. All right, now the other one, 2x minus 4y equals 8. Remember, we changed that to y equals 1/2 x minus 2 in slope-intercept form. Half x minus 2. And when we graph that, -2, up 1 over 2, up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2, down 1, left 2. Beautiful. And we can connect the dots like so. So with that being said, with this system of equations, Notice our solution is where they intersect. Well, where do these points intersect? They intersect at the point here, which is the point 2, -1. So the solution would be to this system of equations would be the coordinate 2, -1. Because if I plug 2, -1 into both these equations, it would work. So that right there is our solution. And that's how it works. That's really the trick to it here that we're going to talk about today. We're going to graph both lines, see where they intersect, all right? So let's try letter A together here. Letter A, 3x plus y equals -2, x minus 2y equals -3. Well, both of these are in standard form, so I'm going to try my best to get these into slope-intercept form. So I'll say 3x plus y equals -2. Let's see, to get y all by itself, I just need to subtract 3x. So y will equal -3x minus 2. With that, I can graph it. -2 is here, down 3, right 1, up 3, left 1, left 1. There you go. Try to connect these dots to the best of my ability. Beautiful. All right, now the other one, x minus 2y equals -3. X minus 2y is -3. All right, so to get y all by itself here, I'm going to subtract x. So I'll have -2y equals -x minus 3. And divide by -2, divide by -2. So I'll have y equals 1/2 x plus 3/2. All right, well, this might be a little more tricky. 3/2 is, whoa, goodness. I want to jump ahead. We're not quite ready for that yet. 3/2 is 1.5. I'm going up 1/2 over 1 or up 1 over 2. I can do that from here. There you go. Down 1, left 2, going this direction. Excellent. And we can connect our dots like so. And notice, where do these points, where do these lines intersect? Well, they intersect at this coordinate point here, which is -1, 1. So our solution to this system of equations would be the coordinate point, -1, 1. There we go. All right, let's try one more together here. Looking at letter B, both of these are in slope-intercept form, so not bad. Y equals 1/3 x minus 2, y equals -2x plus 5. So looking at our first one, we have a slope of 1/3 and a y-intercept of -2. So -2 is right here. Slope of 1/3 tells me up 1, right 3, up 1, right 3, or down 1, left 3, down 1, left 3. There we go. I can connect these dots. Gorgeous. Alright, and then we have y equals -2x plus 5. So that one tells me my slope is -2 and my y-intercept is 0, 5. So that slope tells me I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, right 1, down 2, right 1. Now notice, I can see right now my solution is going to be 3, -1. But showing my work includes graphing both of these lines. So please be sure to finish graphing both of these lines. And like we said, that solution is where they cross. It is indeed 3, -1. All right. Not bad. What I would like you to do, why don't you go ahead and try letter C on your own. Go ahead and pause the video. Try letter C on your own, and then we'll check that together, all right? Go ahead and give letter C a shot. We'll check it together here in a bit. All right. Let's see how we did with letter C. So y equals -1/4 x plus 4. So that tells me my slope is -1/4 and my y-intercept is 0, 4. Okay, so 0, 4 is right here. And from there, I'm going to go down 1, right 4. Or up 1, left 4. And I can connect my dots like so. Beautiful. Not bad. All right, 3x minus 4y equals 0. Standard form. Let's get in slope-intercept form. So we'll subtract 3x from both sides. So I'll have -4y equals -3x. When I divide by -4, notice that the y-intercept here is just going to be 0. So y is just going to be 3/4 x. So y equals 3/4 x. And you can go ahead and say plus 0 if you want. Tell you that y-intercept is 0. The important thing to know is we're going to go up 3 over 4. Or down 3 left 4. And then try to connect these dots to the best of our ability. Not bad. Alright, so did you find your solution to be the coordinate point 4, 3? Hopefully we did, because that's where those two lines intersect. Excellent. One more today. Let's try letter D. Go ahead and let's go ahead and give letter D a shot on our own. So go ahead and pause the video, try letter D, and then we'll check it together, alright? Give letter D a shot. Alright, let's see how we did here with letter D. Y equals 2x minus 2. So that tells me that my slope is 2, my y-intercept is 0, negative 2. So from there, negative 2, a slope of 2 tells me up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1. There we go. I can connect those dots. If I can draw a straight line, there we go. Not bad, not my best, that's okay. Alright, 6x minus 3y equals negative 12. Let's get this in standard form. So I'm going to subtract 6x from both sides. So we'll have negative 3y equal, or sorry, let's get this in slope-intercept form. It's currently in standard form. So I'll have negative 6x minus 12 divided by negative 3 divided by negative 3. Well, remember, a negative divided by a negative gives me a positive, so I'm going to have 2x plus 4. Interesting. Y equals 2x plus 4. So that tells me my slope is 2, my y-intercept is 4, so I'm going to up 2 over 1, up 2 over 1, 2 over 1, up 2, 1, up 2, 2. What? Interesting. Alright, well, let's see here. Notice, well, these lines don't cross. These are parallel lines. They have the same slope, different y-intercepts. That means that this one has no solution. And that's going to be where we stop today. I want you to think about how it's possible to have no solution with these parallel lines, right? They'll never intersect, and therefore there's no values for the variables that will make both of them true. There's no point that's common to both of the lines. All right. Now, as we continue this, once we finish these notes, we're going to talk about a couple other situations that are possible. We're going to have no solution, one solution, which is what we had with all of our other ones, and we'll also talk about infinite solutions, all right, and how those can occur. But for now, we're going to call it a day. So this is Mr. Carter signing off. I'll see you next time.